Hi, Assalamualaikum. My name is Muhammad Faiz Farhami Rohizam and my metric number is DE220084. So we are from group 2, section 3. We will present about our group project is design and simulation of a DC AC system for an RL load. Okay, firstly we go to the introduction. Okay, for the introduction, a DC to AC system is a critical power conversion setup that transforms direct current or DC into alternating current or AC using an inverter. This is essential because many energy sources such as batteries and solar panels produce power in DC form. However, most electrical appliance industry system and power grids operate on AC. The inverter plays a vital role by converting the steady DC voltage into an alternating waveform. It also adjusts the frequency and voltage to match the requirements of connected device. These systems are widely used in renewable energy applications such as solar and wind power, in electrical vehicles, and for backup power solutions. By bridging the gap between DC source and AC power device, DC to AC systems are crucial for advancing renewable energy technologies and ensuring reliable power delivery. This project is focused on design a three-phase inverter to meet specific requirements such as output frequency and voltage, while maintaining efficiency and minimizing harmonic distortion. Okay, so next we go to about the circuit design. The primary objective of our design is to construct a three-phase inverter system capable of producing a 50 Hz output for sine wave. As for the switching frequency, we use 20 kHz and 400 volts line-to-line voltage for an RL load. The design begins with a sinusoidal pulse width modulation or SPWM scheme. The SPWM process generates three sinusoidal waveforms. It is separated by a 120-degree phase difference. These sinusoidal signals serve as reference signals, which are compared to high frequency triangular carrier signal. When the amplitude of the sinusoidal signal is greater than the triangular signal, specific switch S1, S3 and S5 are turned on while the other are turned off. Next, these switching signals S1 to S6 are used to drive the 6 isolated gate bipolar transistor or IGBT. In the inverter circuit, the IGBTs are chosen for their high voltage handling capability up to 100 volts and their reduced switching losses, which ensure efficient DC to AC conversion. After the switching stage, we add the LC filter. This filter is designed to block high frequency noise and allow only the desired sinusoidal waveform to pass through. Okay, finally, the system includes an RL load which consists of a 14 ohm resistor and 1 mH inductor to simulate real world conditions. This setup ensures that the inverter output meets our design specification of 50 Hz and 400 volt line to line by maintaining low total harmonic distortion or THD within the target range of 5 to 9%.
Assalamualaikum, my name is Koyum and now I will present our design calculation for our group project. So for our design calculation, it consists of three calculations, which is load, THD and lastly the LC filter. So for the load calculation, we first find the V phase, which is the 230.94 volt, and then we find the Z phase, the current we gain from our data sheet, which is 22.3 amps. So we are able to determine the Z phase to be 10.356 ohm. So by assuming the inductance to be 1 mH, we are able to find the resistance, which is 10.351. Okay, so for the next part is the total harmonic distortion calculation. So by obtaining the parameter from the previous calculation, such as the R, L and power factor, we also have the parameter which is the V line to line, which is 400 volt and frequency, which is 50 Hz. So first we need to calculate the voltages from N1 to 9, which we have gained the value from N1 to 9, and then we need to calculate the impedance from N1 to 9. So for the impedance, the value of the impedance from 1 to 9 is constant, which is 10.35 ohm. And then we need to calculate the currents IN for N1 to 9 and the RMS currents for N1 to 9, which is we able to gain the result of the I1 to 9, which is 32.5 amp, 10.82, 6.49, 4.64 and 3.61. And then we can calculate the value of the RMS by dividing by square root 2, which we gain the value 22.95, 7.65, 44, 4.59, 3.28, and 2.55. So by obtaining this value, we can calculate the total RMS current, which is 24.96 ampere. And for the last part of this total harmonic distortion calculation, we can calculate the total harmonic distortion, which we are able to obtain the value of 0.429, which is 42.9%. So for the next calculation is the LC filter calculation. So we use the switching frequency of 20 kHz, and for our inductor, we are able to obtain the value of 2.37 millihenry, and for our capacitor, we are able to obtain the value of 2.96 microfarad.
My name is Muhammad Fadlan Hazim Karfazila, and my number is D22105, and I will present to you about our methodology. Okay, for the first one, system design. We use the inverter circuit configuration, which is we design it in a three-phase bridge arrangement. We utilize 6 LGBTs, and we also use the motor for the output, the solar panel for the solar panel, and the component includes some generators, which is RYB, to represent the three-phase. Okay, next, SPWM signal generation. We use comparators to produce solid SPWM signal. Logic generates complementary signal, and SDT pairs controlled by SPWM signal, like S1 with S4, S2 with S5, and S3 with S6. Okay, for the simulation, we got 2 phases. For the first phase, simulation without AC filter. In first phase, we get set reference current and voltage waveform. For the second phase, simulation with AC filter, we design the with filter designed by optimal values, which is we use the value of inductor is 2.36 millihenry, and the value of capacitor is 2.96 microfarad. Okay, for the third one, perform AC filter implementation. The purpose we use it is to reduce harmonic distortion and to smoothen AC output waveform. The configuration of filter implementation is the inductor with connect. The connection we use for the inductor is series, and the connection we use for the capacitor is parallel. Performance analysis, and we analyze top parameters, which is the voltage ampere waveform and total harmonic distortion via power guide law. Okay, for the last one is validation and compliance. To succeed this project, we need to achieve THD level within 5 until 9% of THD level. Okay, that's all for me. Thank you.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Iqbal Arifin Hadi. So now I'm going to present about our design for component, which is from our datasheet. So for the load, we have chosen 11 kilowatt motor, three-phase motor, and the data we get from this table, which is a typical three-phase motor data. So we choose 11 kilowatt motor here, and we have we get the current from the datasheet, which is 32.3 amp, and also power factor of 0.84. So from this data, we can assume the inductance here, and we can work through the calculation and get the value of R. So now for the supply, which is the DC supply. So we use solar panel to generate the DC power, which is so here is our datasheet for the solar panel. So here is from Hymo company, which is if we choose this model, the 550 watt model, so the normal operating condition, you can get 411 watt from one panel. So if we divide 11 kilowatt to the 411 watt of panels, so we can get, so we need at least 36 or 37 panels to power the 11 kilowatt motor. So now this is our choice for the IGBT. So this both this the first IGBT is single IGBT from Infineon, and the second one is also IGBT, but there are 6 IGBT in one pack. So this the second one will, if we use the second one, we will it will help to compact the design. So this is our design. This is our switching part, and this is our inverter part. So this is our filter, which is this is the inductor, and this is the capacitor, and this is our three-phase load. Okay, now I'm going to present about our simulation result. So this is our voltage waveform, which is from the circuit without the LC filter. So we can see here a lot of disturbance and harmonics from the circuit. So the THD here is 68.58% from the magnitude of the frequency at 325 volt. So this is our waveform of filtered voltage. You can see here after we put the LC filter, the voltage waveform is smoother, and we got the THD of 0.94%. And for our current waveform for the unfiltered circuit, we can see here the THD is 4.56%, and for the filtered circuit, we get THD of 1.26%. So as conclusion, this project successfully demonstrated the design and implementation of DC to AC inverter system by utilizing SPWM-based IGBT inverter. So this system is achieve significant reduction in total harmonic distortion (THD) through the incorporation of LC filter. So from our simulation here, we get THD, the reduction of THD. For the voltage, we get 6.38 from 68.58%, and for the current, we got 1.26% from 4.56%. So this result underscore the effectiveness of our selected design to improve the waveform quality and ensuring operational efficiency. So this the optimized LC filter and our testing, analysis approach validated the system reliability for intended application and Malaysia standard of industrial power system. So that's all from us. Thank you.